Hi, welcome to this video on angle relationships practice. We're going to look at a few relationships that angles have when they are adjacent, and we're going to use that to write equations. And so you're going to see the most basic ones are the first three that we're going to look at here in examples 1, 2, and 3. And so for each time, we are going to identify the relationship, write an equation, solve the equation, and then use that to find the missing angle. So let's get started then with number 1. So number 1, the relationship that we have is complementary. It's complementary because it's making a 90-degree angle. So I'm going to be lazy and I'm going to write comp. And that's as good as you don't write just C. That's super lazy. But this is only a little bit lazy. So I'm going to write comp here. And then I'm going to write my equation. I always write the unknown first because I like the variable to be on the very left. So I'm going to write angle x plus the 72-degree angle equals 90. And this is the simplest of all equations because it's just a one-step equation, and I'm going to subtract. So the next step here is to solve. So I'm going to solve by subtracting the opposite, and then I'm going to get x equals 18. There's a little x equals down here for me, and that's right here. I'm going to get x equals 18. Now for me to check it, I'm going to substitute that value back into the diagram that I have. It's saying here angle x is 18 degrees. So that means that this is 18. Or saying this angle, the missing angle is x degrees. So that means that if it's 18 degrees, then I should add these two and this should equal 90. So I'm going to add 72 degrees plus 18. And when I add them together, I get 90 degrees, so it checks. Yay. So there's the first one. I'm going to pause this video now and show you the solutions. As you do, you're going to pause the video, and you're going to do 2 and 3, and then you can kind of turn it back on and you'll see my solutions for those. So you can see that I've solved angle for number 2. I solved for x because it was a supplementary relationship and they added up to 180 degrees. So I wrote the equation that x plus 34 equals 180 degrees. And then I subtracted to solve because that's the opposite of add. And I have 146. So that would mean that this angle here would be 146 degrees because x is the degrees of that angle. So that would mean that I should be able to add these two angles together and they should equal 180. So I add them together and I get 180 degrees, and that's my check. Yay. Now when I come over number 3, they told me that angle 3 is 113 degrees. So I wrote 113 degrees in that angle. That's how I used the diagram to help me. Then it did not give me a value for angle 1, and it didn't give me a variable. So I chose x to represent the unknown measurement in that angle. Now, these angles are vertical. I don't even bother abbreviating that because that's easy to write. And vertical angles are congruent, which means their measures are equal. So I can say that this equals this. They are equal. So my equation is very simple. It's just x equals 113 degrees. That's my equation. It also happens to be the solution because I've solved for x. Now I'm the one that made angle 1 x, so I can't leave it like this. I have to write that the measure of angle 1 is 113 degrees. And how can I check it? They're the same. I'm done checking it. So there you go. That's examples 1, 2, and 3. I like to box our solutions. So let's look at some more difficult problems. Number 4 isn't really any more difficult, except that it can be deceiving because the way this is drawn, it looks like a vertical angle relationship, but they're talking about angles. They're talking about angles 3 and 4, and angles 3 and 4 are not vertical. Angles 3 and 4 make a straight line. They are supplementary because when you put them together, you get this straight line here, this straight angle. So this is an example of a supplementary relationship. And again, it doesn't give me a variable for angle 4. So in order for me to write an equation, I need to have an unknown. So the unknown, the x, represents the measure of angle 4. So then I'm going to write my equation as x plus 83 equals 180 because they are supplementary, and then I will solve it. So x equals 97. That means the measure of angle 4 is 97 degrees. There you go. So they were actually supplementary, even though they looked like a picture of vertical angles. The vertical angles would be, here, I'll color them in for you. So this angle here and this angle here, those two are vertical. They're both 83 degrees. And then this angle here and this angle here, they're the ones that are vertical, and they're both 97 degrees. That means if you if you go all the way around, if you add all 4 of those angles together, that's called a full rotation, they'll equal 360 degrees. And that'll be useful later. So the next 2 examples are not difficult, except for the fact that they have they have 2 different situations in them that we'll look at. So example 5, the relationship between them is complementary. And it's complementary because they make that 90-degree angle when you put them together. So when I go to write the equation, this time the degrees of the angle, the variable x just represents a value, but the angle itself is 5 times x. So when I write my equation, this angle here is 5x, and I always write the one with the variable first, plus, and then 25 is the complement, and together they equal 90 degrees. So now to solve this is a 2-step process. So you can pause the video now and solve that equation. So I solved it, and I have x equals 13. You can look at the way I solved it and see if it matches what you did. So that is actually the value of x. I'm going to take that value and substitute it in here back into the angle. The angle here is 5 times x. That means I'm going to do 5 times 13. Why am I doing 5 times 13? Because x is 13. This is my substitution. When I do that, 5 times 13 is 65, which is good because right here we have 5x equals 65. Remember, we already found that when we were solving. So 5x equals 65, then this equals 65 degrees. And then that's good because now I can check and see if my answer makes sense. Because angle 25 degrees plus the angle that's 65 degrees should add up and make 90 degrees. And it does. So 90 equals 90, check. So there I've checked my solution. So I hope that you understand the difference between finding what x equals and finding what the angle equals. In the first several examples, x was the degree of the angle, but it's not always going to be that way. Example 6 presents a new problem. So let's look at that equation. First of all, the relationship makes a straight angle, so the relationship is supplementary. And any time that you want to try this on your own, you can always pause me and try it and then check it. So it's supplementary, that looks like a V, because they add up to 180. So if I write that, I'm always going to pick the angle with the x in it first. X plus 40, that is this angle here, plus 106, those 2 angles together. So this is the first angle and this is the second angle. When I add them together, I get 180 degrees. So in this problem, this is actually going to be a 1-step solution, but it looks kind of weird the way it is. And I've seen people in the past just subtract twice, and that works. You can do that if you want, but what I'm going to tell you to do is when you have a situation here where you have like terms on one side of the equal sign, and you can actually add things together, you should do that first. So we're going to simplify first. So I have 40 plus 106. I can add those 2 numbers together because they're both constants. That gives me 146. I still have 180 on the right. And I don't have any other x's to add with this, so I can't do here. Now I have a 1-step equation to solve. I had x plus 146 equals 180. And the opposite of add is to subtract. So I'm going to subtract 146 from both sides. And then x equals 34. Okay, but that's the value of x. To find the angle that I'm missing, I'm going to go back in here and say, well, if this angle is x plus 40, I'm going to replace the x with 34, substituting, plus 40, because why am I doing that? Look, x plus 40, and x is 34. So 34 plus 40 is 74. That means this angle here is 74 degrees. So I should be able to add 106 plus 74 and get 180 degrees. They should add up to 180. And when I add 106 and 74, I do get 180. So yes, it checks. So that's the basic idea, is that you identify the relationship and then write the equation and then solve the equation and then find the angle measurement. It's just a matter of how difficult it's going to get. If you look at examples like 7 and 9 and 10, these are examples where you're going to be adding the angles together and they're going to equal something. And you're going to have to simplify first. So in 7, 9, and 10, it's like the example that we just did together, where you have to simplify and then solve. And I will do number 9 then, before we go. But number 8 is a little different because of the kind of situation that we're looking at. So number 8 could be tricky for people, although it's actually pretty easy. Number 8, the relationship is vertical. Vertical angles are congruent, which means their angle measurements are equal. So what that's telling me is these two angles that are across from each other are equal. So that is my equation. They are equal. They don't add up to anything in particular. So that means I can make these equal. Well, look at the way this is written. It's written as 14 plus 6x. And I don't like that. Because I don't like when the 14 is plus 6x. I have addition here. I can use the commutative property and make this 6x plus 14. I'm going to do that for myself because I can do that when it's adding, so I might as well. So my equation will be 6x plus 14, that's the one angle over there, equals, what does it equal? 134, because it equals the same measurement as the other angle. So now I have a two-step equation to solve. So write down this equation, pause the video, solve it, and come back. So now you can see how I solved it. Subtracted 14, then divided by 6, I have x equals 20. Now, that tells me what x equals. This angle here, I'm going to go and substitute in the right way, should be 14 plus 6 times x. Well, x is 20, so it's 14 plus 6 times 20. And when I do 14 plus 6 times 20, you would multiply first because the order of operations. So 6 times 20 is 120, plus 14 is 134. Well, that's good because it's supposed to be the same measurement as the other angle, and it is. So that means I have the right answer. So we're going to look at number 9, and then you can do 7 and 10 on your own. All right, well, number 9 is a lot like 7 and 10 in that when you write the equation, you have to simplify first. It's just number 9 is kind of weird because it has the division, and I know that makes you uncomfortable. So let's look at number 9. So number 9, the relationship is complementary. I know it's complementary because I see this box here, and that means that it makes a corner, and ones that make a corner are complementary. And remember, it's always 90 degrees in the corner. Funny. Anyway, so I'm going to write the equation. If they're complementary, they add up to 90. So that means I'm going to start with this angle here. I'm going to write what's inside there, x divided by 3 plus 1. And then the second plus the other angle. So plus this angle here, 62. They equal 90 when you add them together. So now I'm going to simplify. That means I'm going to put these together here. first because they're both constants. So I'm going to add 1 plus 62 is 63. And this is, so x divided by 3 plus 63 equals 90. So to solve this, it's a two-step process. I'm going to subtract the constant from both sides. I'm subtracting because that's the opposite of addition. Now I have x divided by 3 equals, I'm going to do 90 minus 63, I get 27. Yeah. Now, the mistake that people make is they think that x equals 9 because 27 divided by 3 is 9. But it doesn't, because I am dividing x by 3, and when you divide x by 3, you get 27. So to solve, I did the opposite of divide, which is multiply. So I'm going to multiply both sides by 3. So on the left, I write 3 over 1 times x over 3, and that would give me 3 over 3, which is 1, even as a 1. So 1x equals, and 27 times 3 is 81. That means x equals 81. Now that doesn't mean that that angle equals 81. I know that angle doesn't equal 81 because it's smaller than the other angle, and that wouldn't make any sense. So the angle doesn't equal 81, x equals 81. So when I substitute x back in here, I have x divided by 3 plus 1. Well, what's x? 81. So 81 divided by 3 plus 1. And when I check that in the calculator, I get 28 degrees. Well, does that check out? Let me check, because 62 degrees plus 28 degrees should equal 90. And when I add those together, I get 90. So it checks. So that's the examples from pages 10 and 11. And try numbers 7 and 10 on your own and check them in the answer key.